So the contents of the presentation, what we'll be doing is just a quick introduction to what we consider digital twin. It is a term that has been thrown around quite often, and it does mean different things for different people. So we just kind of nail that down for what Anglo is all about. Then we'll get into the meat of the presentation. We'll go into the background from an Anglo-American point of view, and then we'll go into the architecture. We'll discuss the benefits of these digital twins, and then we'll just have a quick peek at what's next and what Anglo is really looking for in the future. Okay, so what is a digital twin? So a digital twin, just in broad terms, if I may read off the slide, it's just an asset that provides a virtual replica capable of simulating all important characteristics of the physical environment. Nothing new to the audience there. In the environment, designers, operators, and engineers can accurately obtain the results of an improvement through simulation. There's absolutely nothing new there. However, what I would like to add, for Anglo-American, the digital twin comprises of two things. It's a process twin and it's a device twin. Now, I will be referring to these quite often in the presentation. And we are trying to represent the various layers of the plant's control system hierarchy. And very often we are asked, is this for new plants? No, it is applicable to both greenfields and brownfields project. So we use, or our digital twin is defined from the lowest level, the actual equipment, the dynamic responses, the pipes, the tanks, the conveyors, the flow rates, the densities. On top of that, we have the instruments and devices, like the SIMO codes, that drives the instrumentation, the actual things in the field. And on top of that, we have our virtual layers, which is typically starts with the PLC or the DCS, the SCADAs, the advanced process control, the management execution systems, or the short interval control, and all the advanced layers on top of it. All physical hardware is digitally replicated. We'll be talking about that, such as the physical PLCs becomes a virtual PLC, and the actual plant becomes a virtual plant. Our partner companies for this is Honeywell. We use Rockwell and Siemens PLCs also fairly widely. Okay, so in terms of the background and getting into the meat of the presentation, just there is a bit of repeat here, and we find it fairly useful especially when we are presenting this to our stakeholders on the plant. So what is it? What is a digital twin? It is a digital representation of the real operation, as we've said, but it entails a high fidelity process simulation, which is connected to the PLCs and the DCS via that device simulation. And then what you have, you can put an operator in front of an actual SCADA that is connected to the actual advanced layer on site. And you can immediately see the benefit and that alone will have on any simulation. So the objective is, first of all, is to have an operator training station, like I mentioned, putting operators in front of a plant that reacts, that first of all looks, it feels, it reacts as a plant. It's got the actual control system connected to it for these operators to play with and to fail on that level. Okay, so that enables SCADA familiarization, scenario identification. In addition, you also have a simulation for optimization, which is it speaks for itself. It's useful in debottlenecking studies and scenario testing. We've got advanced process control and what we call the plant-wide optimizer. I know in the Honeywell world that's more referred to as the DQP. We have assistance for the advanced layer through the use of inferentials, using the Honeywell design suite, model identification and optimization, running a digital twin in parallel. The PLC standardization is also something that is very close to our hearts, as it becomes extremely useful doing PLC standardization and modernization in an offline plant. And then ultimate goal is having a digital line, and it won't be a presentation about a digital twin if we don't throw in the buzzwords such as the fourth industrial revolution, which is something we absolutely subscribe to. What is it not? And it's something we often ask. So it's nothing to do with the geological model of the plant and the feed. It's not structural, it's not mechanical, and it does not include the IT systems infrastructure. Okay, so Anglo uses an IC or a S88 structure, which is comprised into 5 levels. Level 0 is the actual plant, mining, logistics. Level 1 is the instruments, devices, equipment, like I mentioned. Level 2, part of level 2 is the actual PLCs, and the other part is the software, which comprises the sequences, the PID, the control, the base layer control algorithm. Level 3, which is typically at an execution of between 10 seconds to 30 minutes. That is your advanced control. We use we standardized on the Honeywell Forge software. We still call it Profit. I believe it's moved on to Honeywell Forge. Level 4, we've got plant part optimization, where the Honeywell DQP we use for that layer, and then on top of that we have a level 5, which is something we really are introducing to the plants lately. So of this entire hierarchy, you can immediately see, and it's mentioned on the left-hand side of the slide, that level 0, level 1, and level 2.1, if I may call it that, is actual physical hardware in the field. It's either pumps and pipes or drives or PLCs. Now, our job, and on top of that, it's just digital. It's all control layers. It's all in a computer. So our job, part of my job, is then to make that physical world bit a digital world. And how do we do it? We've got so just zooming into those couple of layers, we have the level 0, which is the actual plant. We use Unison USD, the Unison design platform to create high fidelity simulation. Level 1, the devices, we use other software such as, if it's a Siemens PLC, we use Simit. If it's a Rockwell, we use Echo or Emulate 3D. And then on top of that, the first part of the level 2 is where you have the actual hardware. That is a virtual controller. The software is a direct replica, and you can immediately see, if you can have a direct replica of the HMI and the actual PLC, you can have a system where you put an operator in front of it and it reacts, and that's connected ultimately to a high fidelity simulation in the Honeywell design platform, reacting like the plant does using the actual control system. Okay, just a little bit delving into these layers. Level 0, as I said, is our high fidelity layer of the plant, is the Honeywell Unison design. There's an interesting story at Quellaveco. It's a huge copper mine in Peru that's starting up, that's being commissioned at the moment. But during the commissioning phase, there was a bit of a really good story where we had a look at the pumping station, and we could not make this pumping station work using Unison design. And we had the experts in, we had everyone. Ultimately, it was found that the design was flawed. And it caused us to change the design. And the OEM came back to us after several heated discussions and admitted that the design was flawed. But it was a great success story for the Unison design platform that pointed out before the plant was built that there's a fault in the design, which would have caused us quite a lot of downtime during commissioning. Okay, not much to see. Level 1 and 2, it's a Simit / Echo. It's Rockwell and Siemens software connecting to the PLC. It's just some examples of how it looked like. Now let's have a look at the benefit of these systems. Obviously, one of them is just you have a dynamic simulation. You can use it for case studies, scenario studies. The one that you see on the screen, the example is where we tested a crusher section. Again, the benefit I would like to reiterate is that it is often we do even dynamic simulations. We do these simulations, but it's not connected to the control system. So our simulations, the plant don't trip because the control system is not there. It doesn't optimize similar to what it would have done. So it's just that extra layer of reality that is brought. And we could test various of blasting alterations of the mine, control alternatives. We used different configurations of the bins. different pressure settings, and ultimately we decided on a combination of the pre-mentioned strategies, and we went on to implementation based on that. The Honeywell Workforce Competency Process Training Simulator, where we can put people in front of an actual SCADA environment, and like one of my people used to say, we start throwing spanners at them, and they need to navigate through the cognates of the issues that we put in front of them. We've done a couple of these. We've done one at Quellaveco. There you can see the training station. The plant hasn't even been built yet. All the operators are very confident using their own live simulation, or beg your pardon, own live SCADA system, their HMI. They know they've had SCADA familiarization training using ultimately the plant simulation in unison design to mimic the behavior of the plant, and obviously the control system, which is another Honeywell product that we use, the advanced control system. Okay, and we also use it for scenario training, where we wanted to teach them how to start up a plant, stop a plant, change a pump, all of those type of things. Okay, then just lastly, I would like to, on the benefits, just quickly want to go into one of the things we found with virtual commissioning, where we virtually commissioned the plant's control system, where typically an Adminis Rio plant, one of our other plants, we received the code, the code from the vendor, which in this case was a Rockwell vendor. And typically what you would see, this is nothing against Rockwell, is when we get the site acceptance test software, we skip a virtual commissioning and training step. We go straight into loop checking, training based on a static SCADA, and ultimately we go into wet commissioning. However, at Quellaveco, with this entire digital twin, of which Honeywell has got a couple of products featuring, we included a virtual commissioning and training. Now, so before we go to loop checking, we've already done the training on the SCADA. We've done a virtual commissioning of the software, both the PLC and the advanced layer software, and only then do we go into wet commissioning. Now, the results was quite astounding. Bigger pardon, the legend's not very eligible. The orange is the one at Minas Rio, and the green is the one is the plot for the Quellaveco solution. On the y-axis is the amount of issues that was reported with the control system. What you can see here, at the point where the acceptance testing, the program was received, the amount of issues that was registered is basically the same. However, during a period where there was a virtual commissioning at Quellaveco, but nothing at Minas Rio, the virtual commissioning added or spotted an additional 1,000 to 1,500 additional issues with the process simulation, or I beg your pardon, with the control system, as was delivered to site. So you can imagine having 1,500 issues during wet commissioning that you have to sift through. It just puts an amazing strain on the commissioning process. And obviously what we've seen now is a reduction in the commissioning time, which is something we're really proud of. Lastly, we're heading towards a digital mine where any piece of equipment, let's for instance say a pump, is connected to a simulation. It's connected to our advanced suite of software. It's connected to, you can get all these information in the virtual world. Then we would like to connect it to a 3D plant, which we're busy doing, and all sorts of, we're using a document management software called Cormos. It's also another product, but that gives you the electrical drawings, the instrumentation diagrams, and all sorts of information on that while you are navigating this plant in the digital world. That's what we're doing at the moment, doing some 3D plant scanning. From the 3D plant scanning, we suck in the old PNIDs, which in some cases are hand-drawn. It's difficult in those cases, but ultimately using the 3D plants that we are taking, we are delivering online PNIDs, red line PNIDs using these 3D environments. And ultimately, we would like a completely virtual environment where you can walk around and get an exceptional amount of all the engineering information from our document database. That's just a little bit on where we're heading, and just and of this, the Honeywell suite of software does really come into play, where all of this is connected ultimately to a process simulation, which is driven with a high fidelity nature from the use and design environment. Thank you very much.